There's an object drifting through our solar system right now, labeled a comet, dismissed as routine, until a series of deep field images revealed something no natural body should have. A geometric void inside the coma. Not turbulence, not pixel noise, a structure, stable across multiple frames. Then in frame number 4, that structure did the impossible. It changed shape, not size, shape, as if something inside 3i Atlas reconfigured between exposures. And the moment the coma thinned during the 5th cycle, the core became visible, not as a rock, not as an icy nucleus, but as a layered assembly with edges, ribs, and a central cavity that rotated exactly as the shutter opened. When the operator saw it, he literally reached forward and pulled the monitor's plug. He only said one thing: "This is not for everyone's eyes." If this sounds like a maneuvering object reacting to observation, you're not alone. Subscribe. The images get worse, and the final frame changes everything. The first thing the team noticed wasn't the shape. It wasn't even the brightness spike. It was the shadow, a cold, geometric absence of light, right where physics said nothing solid should exist. A void with straight edges, stable, sharp, in the middle of a violently turbulent coma. When the final batch of images arrived on the secure server at the University of Colorado's Astrophysics Data Center, nobody reacted at first. Someone joked that the timestamp looked wrong. Someone else said the contrast must have been miscalibrated. But within minutes, the room grew unnaturally quiet, the kind of silence that doesn't ask for attention, it demands it. What they were looking at didn't behave like dust, or ice, or anything drifting through the outer solar system. And Avi Loeb's probability model, the one that had been circulating privately for weeks, was suddenly not just an academic curiosity anymore. According to his updated calculations, the chance that 3i Atlas encountered Jupiter in the way that it had, on the trajectory that it had, with the timing that it had, purely by natural dynamics, was 0.00005%. If you think that sounds orchestrated, you're not alone. By the end of the night, some of the researchers had quietly started using the word they weren't supposed to: parking. But I'm getting ahead of myself. Let's slow down and look at how all of this started, with 6 photos that should have been boring, routine calibration frames, photos the public was told were invalid, photos NASA and ESA have since buried under 3 layers of internal review. Tonight you're going to hear why. And by the time you reach the end of this series, you will understand exactly why the senior imaging technician, a man with 23 years of experience cleaning noise out of Hubble and Webb data, physically pulled the monitor's plug when he saw the 6th frame. He thought he was protecting the team. From what? He couldn't explain. Not yet. So let's rewind. It began in late October inside the high-resolution imaging lab of the University of Colorado. The research group there had spent months lobbying for something astronomers rarely receive: a tightly spaced time series of deep field exposures targeting the inner region of a comet-like object taken over a complete 16.16-hour cycle. That cycle, the now famous heartbeat period of 3i Atlas, was already causing trouble in the literature. The brightness rhythm was too clean, too stable, too perfectly periodic for a coma driven purely by solar heating. So the team's proposal was simple: give us 6 snapshots, evenly spaced across one full pulse, and we'll determine once and for all whether the brightness modulation is rotational, thermal, or something else. They didn't expect drama. They didn't expect controversy. They certainly didn't expect fear. The principal investigator on the project, Dr. Daniel Harlow from Boulder, described it later like this: "We thought the worst-case scenario was wasting telescope time to learn nothing. If you'd told me that the real nightmare was learning too much, I would have laughed. But he wasn't laughing when the third image loaded. The first frame came in at 11:02 p.m. Mountain Time. It looked normal. A diffused coma, slightly asymmetric, no nucleus resolved. That matched expectations. Hubble could only give an upper limit of about 2.8 kilometers for the nucleus. Anything smaller was effectively invisible behind the glow of dust. The second frame arrived 3 hours later. A little brighter. The breathing cycle was entering its upswing. Again, standard, nothing unusual. But the third image broke the room. At first it looked like a smudge. A strange one, too centered to be random noise, too crisp to be a cosmic ray hit, but still just a smudge. The researchers circled around the main workstation, leaning in, squinting, adjusting brightness levels like surgeons trying to identify a tumor on a scan. Someone suggested it was dust on the CCD. Someone else said maybe a diffraction artifact. But Dr. Harlow didn't speak. He just stared, eyes narrowing, jaw locked. His hand hovered over the mouse as if he were afraid touching anything might make the thing on the screen react. "Can you isolate the luminosity gradient in the inner coma?" he asked finally. The technician nodded and ran a quick separation. That's when the smudge stopped being a smudge. The inner coma cleared just enough for the shape to resolve. Not fully, but unmistakably. A boundary. Curved in some places, angular in others. Regular. Intentional looking. Like the corner of a geometric frame buried beneath swirling dust. But geometry doesn't belong in comets. Cometary nuclei are messy, chaotic, jagged, battered by eons of impacts and heat cycles. They don't form straight lines. They don't form right angles. And they sure as hell don't form repeating symmetrical patterns. "Zoom in," someone whispered. The technician did. Pixels enlarged, artifacts stretched, but the underlying outline held steady, like a skeletal pattern emerging from fog. "Dan," said Dr. Liu, a spectroscopist from Stanford who joined the project late, "tell me I'm seeing this wrong." No one answered. Instead, the imaging tech ran a motion comparison between frame 2 and frame 3. He expected noise, or random turbulence, or at worst, a lens reflection that moved inconsistently with the coma. But the overlay told a different story. The structure, whatever it was, had shifted. Not the whole object, not the coma, just the shape. Shifting in a way that implied rotation. Independent rotation. The kind you get from something solid. Something with edges. Something real. The room got colder. No one touched the thermostat, but the air felt heavy, like the moment before a storm breaks. "What's the centroid drift?" Harlow asked quietly. The tech pulled up the numbers. No drift. It's locked. Absolutely locked. Harlow swallowed. Locked to what? No one said it out loud, but the answer was obvious. Locked to the object's internal frame of reference, meaning it wasn't a projection, it wasn't a lens ghost, it wasn't a glitch, meaning it was there. This was the moment, later described in internal notes, where the team experienced what psychologists call cognitive arrest, a brief freeze in the brain's ability to interpret new information when the data contradicts every known model. The astrophysicists weren't panicking yet, but they weren't breathing normally either. Because here's the thing. Comets don't have interior structures that rotate independently of the coma. They don't have shells, or frameworks, or internal scaffolding. You can't bury a geometric object inside a natural nucleus and expect it to survive millions of years in interstellar space. Yet there it was, buried inside 3I Atlas like a bone inside a body. A bone that wasn't supposed to exist. Someone finally broke the silence. "Harlow, should we report this?" He shook his head slowly. Not yet. Not until we understand what we're looking at. That was the responsible choice, the scientific choice, and in hindsight, the choice that changed everything. Here's the part the public never heard. NASA didn't reject the images because they were invalid. They rejected them because frame 4 was worse. Frame 4, shot at the exact midpoint of the 16.16-hour cycle, didn't just show the structure, it showed it changing. The edges that looked hexagonal in frame 3 were now subtly warped. Not blurred, not smeared, altered, as if the internal mass had reconfigured its orientation relative to the coma. Dr. Liu backed away from the monitor. "Natural processes don't do that," she said quietly. The technician pulled up the log and checked exposure metadata, looking for something, anything, that would explain a shift like that. Nothing. Hardware normal. Pointing normal. Tracking normal. Coma brightness rising smoothly, and the structure, whatever its composition, now oriented at a different angle than before. "It's rotating," Harlow said. "No," Liu countered. "Rotation would maintain shape. This is reconfiguration." The word hung in the air like a blade. Reconfiguration. A concept you use for drones, satellites, machines, not for rocks and ice. "I refuse to jump to conclusions," Harlow said, forcing authority into his voice. "We keep going. Frame 5 should put this to rest." It didn't, but part of him already knew that. Frame 5 arrived just after 3 a.m. By then, everyone was jittery. A few cups of coffee sat untouched, cooling on desks. Someone had turned off the overhead lights without asking. No one turned them back on. The 5th image loaded. At first, they didn't notice anything new. The coma looked slightly expanded, part of the predicted breathing cycle. Dust jets flared faintly. Standard stuff. Then the imaging tech overlaid frames 4 and 5, and the room stopped breathing again. Because now there were streams, not cometary jets, not outgassing plumes, not anything driven by heat. These were narrow, focused, linear, like thin directional exhaust trails. And here's the part that would later set off alarms across 2 space agencies. The streams were pointing against the direction of solar wind pressure, meaning they were fighting radiation pressure, meaning they weren't passive, meaning they were pushing. Dr. Harlow leaned forward. "How long between peak intensities?" 12 minutes, the technician replied. 12? Liu asked sharply. "That's impossible. Comet jets don't reorient in 12 minutes. Even dust loading takes—" "I know," the tech said. "But look." He pulled up a vector animation based on intensity changes. The streams weren't random. They were adjusting, correcting, as if locked into a closed-loop system. Liu exhaled shakily. "These aren't jets. They're controlled thrust vectors." And right then, right on cue, as if the universe wanted to hammer the point home, an alert popped onto the main telemetry screen. 3i Atlas had shifted course. Not by much, just a few thousandths of a degree. Barely a nudge, but it was not gravitationally accounted for. No perturbation from Jupiter, no solar wind anomaly, no mass ejection event. Just a clean, surgical adjustment, like a course correction. Like it knew where it wanted to go and where it didn't. No one in the room spoke for a long time. Then Dr. Grant, the junior postdoc who had been quiet all night, finally whispered, "If it's correcting its trajectory, then it's not just moving." Liu finished the sentence for him. "It's responding." The word landed heavily. Responding. Not reacting, not drifting. Responding. The room felt too small after that, too warm, too alive, and there was still one frame left. The sixth and final image came in at 6:14 a.m. The team had been awake for nearly 20 hours. No one had left the room. When the notification pinged, everyone moved at once, then froze again. Harlow nodded at the technician. "Load it." He did. For a moment, the screen stayed black. Then the coma bloomed open, an expanding shell of gas, unusually symmetric, almost perfect in its curvature. More symmetric than any natural coma the team had ever observed. And in the center of that symmetry, where the haze thinned just enough, the internal structure appeared again. But this time it wasn't just visible. It was facing the camera. Rotated, or oriented, or aligned. There are scientific words for these things, but none of them captured what the researchers felt in their bodies: a prickling heat in the spine, an electric flutter under the skin, the primitive recognition of being observed. The structure's outline sharpened, 6 edges, a hollowed center, like an aperture, or an intake, or something that simply looked back. In the exact moment the shutter captured that frame, the central region produced a brief intensity spike, a flash aligned perfectly with the camera's line of sight. Too faint to call a signal, too synchronous to dismiss as chance. "It's tracking us," Grant whispered, without meaning to. The technician's hand trembled as he reached for the brightness control. Dr. Harlow didn't let him touch it. Instead, he stepped forward, reached over and did something none of them expected. He pulled the power cable from the monitor. The screen snapped to black. "Why did you—" Liu began. Harlow's voice was steady, but cold. "Because this isn't for everyone's eyes." And that was the moment, the exact moment. The story stopped being a scientific exercise and became something else entirely. Something with consequences stitched into every layer of bureaucracy that followed. Because when you see a geometric shadow inside a comet, you question your model. When that shadow rotates independently, you question your assumptions. When it produces controlled thrust, you question the data. But when the structure reorients itself in perfect alignment with your telescope, at the exact instant your shutter opens, you stop questioning. You start fearing what questions might come next. For the next 48 hours, the 6 images stayed locked inside a restricted directory on the University of Colorado's server. No cloud backup, no remote downloads, no automated indexing. Dr. Harlow insisted on that. He didn't use the word containment, but everyone understood the energy behind the decision. They had stumbled on something they didn't know how to interpret yet, and the last thing they needed was premature panic or speculation. Still, panic doesn't care about protocols. It grows on its own, in silence, at 3 in the morning, when the brain replays images it can't categorize. The team didn't sleep, not really. By sunrise the next day, rumors had already seeped through the research floor. Nothing explicit, just the soft pressure of something unusual happening behind closed doors. Someone saw Liu leaving the imaging lab with red eyes. Someone else noticed Grant pacing outside the stairwell, muttering orbital parameters under his breath like a prayer. The usual hum of academic chatter had thinned into something brittle. But no one outside the room knew the truth. They hadn't seen the shape, the symmetry, the way it reoriented itself in frame 6, and they hadn't yet seen what the data looked like once the researchers began processing it properly, smoothing noise, subtracting flare artifacts, enhancing gradient contrast in the inner coma. That work began at 8:17 a.m., inside the same dimly lit lab where the team had gathered the night before. The overhead fluorescence stayed off. Only the glow of monitors lit the room, casting long shadows against the walls. The technician, a man named Oliver Reeves, had barely spoken since pulling the cable from the screen during frame 6. His face looked sunken, drained, but his hands were steady as he reconnected the workstation and pulled up the raw FITS files. Harlow watched him with an expression that mixed exhaustion and determination. "Let's start with frame 3, Harlow said, the first one with the structure fully visible. Reeves nodded and loaded it. There it was again, the faint but unmistakable hexagonal contour sitting in the heart of the coma like a hidden skeleton. Even in raw data it looked wrong, too exact, too stable, too intentional. "Jesus," Grant whispered. "It wasn't a hallucination." "No," Liu said flatly. "We all saw the same thing." Silence fell again, heavy and electric. Harlow folded his arms. "Let's quantify it. If it's real, we can describe it. If it's not, we can disprove it." That was the scientist talking, the part of his mind that needed data to silence fear. Reeves ran a pixel gradient analysis, a simple tool that highlights sharp edges like outlining mountains on a topographic map. On natural comets, it usually creates noise, chaotic zigzags from random dust patterns, nothing geometric. But on 3i Atlas, the gradient reconstruction drew a near-perfect hexagon. 6 vertices, 6 edges, deviation from uniformity less than 5%. Liu leaned closer to the monitor. "That's impossible," she murmured. "Hexagonal symmetry of that magnitude doesn't occur inside a coma. You'd need stable, rigid boundaries, or a magnetic field strong enough to shape the dust. But there's no magnetic signature." Reeves pointed at the spectral metadata. No magnetometer anomalies, no Faraday rotation, nothing that could corral particles into a stable geometric shell. Grant swallowed hard. "So what's left?" Harlow exhaled slowly, as if the air might carry an answer. "If the boundaries are sharp," he said, "they're not from the dust. They're from something the dust is outlining. A shell. A surface. A structure." The idea hit the room like a physical force. Grant took a step back. "You're saying there's an object in there, a solid one." Harlow corrected him gently. "I'm saying there may be angular topography on the nucleus, and we need to explore every natural explanation before we entertain anything else." It was the right thing to say, the responsible thing, but no one missed the tremor in his voice. The truth was simple. Cometary nuclei don't have hexagons. Planets sometimes do, like the storm on Saturn's North Pole, but those are atmospheric dynamics, not solid features. Nothing in deep space, drifting for millions of years between stars, should retain perfect symmetry. Nothing. Reeves loaded frame 4. The room tensed collectively, like a muscle remembering pain. In frame 4, the hexagon was still there, but different. One side was shorter, another seemed elongated. One vertex had shifted slightly inward, not blurred, not distorted, edited. Not by software, by itself. Liu hissed under her breath. "That can't be erosion. That can't be rotation either. That's a shape change." Reeves switched quickly to a frame difference view, subtracting frame 3 from frame 4. Everything except the structure vanished, and what remained looked like a digital blueprint morphing between 2 configurations, the way a satellite might reorient a solar panel or adjust an antenna array. But this wasn't a satellite, not anything built by humans anyway, not drifting 6 million miles from Earth inside the coma of an interstellar traveler. Could it be a thermal stress fracture? Grant offered weakly. Different patches heating at different rates. No, Liu cut in. Thermal stress fractures don't form geometric edges, they don't pivot, and they don't selectively contract
only one side of a polygon. Harlow didn't speak. He just stared. He had seen too much to deny what was in front of them. But science requires resistance. It resists leaps. It resists stories. So he reached for the only rope left: skepticism. "Let's check for optical artifacts," he said. "Internal reflections, ghosting, mirror scatter. We're using a high albedo coma as the backdrop. That can create patterns." Reeves already had that pipeline queued. He ran it. The software highlighted every known artifact: lens flares, mirror ghosts, sensor halos, diffraction spikes. None of them touched the structure. The hexagon remained clean. "Okay," Harlow said quietly. "Run polarization analysis." Another test. Another elimination. Cometary dust is irregular. Polarization signals look messy, scattered vectors pointing in unconstrained angles. But the polarization near the structure showed something else: alignment. Particles around the hexagon were oriented non-randomly, as if an electromagnetic field or a material surface was influencing their arrangement. But there was no detectable field, no magnetic signature, no electric anomaly. Just dust behaving in a way dust doesn't. Grant whispered, "It's aligning around a boundary." Reeves nodded slowly. "Yeah, it's treating it like a surface. A surface hidden beneath the coma, one with straight edges, one that rotated independently in frame 3, one that changed shape in frame 4. If you were listening in the lab, you could hear the researchers' breathing shift, shallow, rhythmic, synchronized by fear. They weren't thinking alien. That word didn't belong in their mouths. When you're trained to interpret data, not stories, your brain reaches for the least impossible explanation, maybe mechanical, maybe artificial in the engineering sense, not the science fiction one. But even that thought hovered at the edge of treason, because to say that an interstellar object contains a reconfigurable geometric structure is to say something that the current framework of astrophysics simply cannot accommodate. Not yet. At 10:32 a.m., they moved on to frame 5, the one with the streams. Reeves opened the raw image. On first glance, it looked messy, like turbulence in the coma's outer shell. But when he ran the directional gradient filter, the turbulence snapped into clarity. 3 narrow plumes, not diverging, not chaotic, all converging along precise angular vectors. Grant leaned in. "Is that a collimation pattern?" "It looks like it, but gas doesn't collimate naturally, unless constrained." "By what?" Grant asked. The answer came from Reeves, but he hated to say it. "By a nozzle." No one breathed. Reeves kept going. "And look at the angles. They're not aimed with the solar wind. They're countering it." Liu closed her eyes. "Active thrust." It wasn't speculation anymore, not interpretation, just observation. Dust jets should always favor the sunward direction, the heat source, but these streams were deliberately angled against both solar radiation and the object's orbital drift. Someone else in the room might have said it out loud, but Harlow beat them to it. "It's station keeping." The phrase felt obscene in the quiet room. Station keeping is what satellites do, not comets. Grant sank into a chair. "How do we write this up? How do we even phrase it?" Liu replied with a strange calmness. "We don't, not yet, until we know we're not misinterpreting a natural mechanism." But she didn't sound convinced. No one did. Harlow rubbed his forehead. "Let's quantify the thrust." Reeves opened the photometric model and calculated the estimated mass flow rate from the brightness of the streams. He froze. Liu leaned over his shoulder. "What is it?" "The numbers are too small," Reeves said. "If this were gas, the mass flow is too low to produce the observed trajectory shift." Grant blinked. "Meaning?" Liu answered. "Meaning The acceleration didn't come from outgassing. A new silence, heavier than the others. "The thrust is not from mass ejection," Harlow whispered. "Something else is pushing it." He didn't say radiation pressure. He didn't say magnetic acceleration. He didn't say micropropulsion. He just let the room fill with the implications. Then finally, Reeves loaded frame 4 beside frame 5 and overlaid the shape. The result stunned them all. The hexagonal structure had changed its configuration in the exact interval that the directional streams appeared, and in the region where the shape retracted, the brightest of the 3 streams originated. It wasn't random. It wasn't incidental. It was an internal adjustment preceding a directed action. Liu covered her mouth. It reconfigured in anticipation of thrust. Not reacting, not drifting, not behaving like an icy rock. Anticipating. The team worked through lunch without noticing. Sometime around 1 p.m., the building's custodian knocked gently on the door, realizing the room was too tense for interruptions, and backed away quietly. By 3 p.m., the researchers had run every natural model they could think of. Fracturing? No, the angles were too precise. Coherent ice crystal growth? Impossible at that size and temperature. Magnetic field shaping? No magnetic signature. Solar wind sculpting? The direction was wrong. Plasma interference? Patterns were too stable. By 4 p.m., they ran out of natural explanations. But scientists don't like running out. They like puzzles. They like limits. But they don't like the void beyond them. So Harlow asked for one more test, the last refuge of skeptics. "Check rotational correlation," he said. "If the structure is part of the nucleus, it must maintain rotational coherence with the coma, even if partially obscured." Reeves ran the test. The coma rotated slightly between frames. The shape didn't. It stayed locked in its own orientation. Independent. Controlled. Decoupled. Liu whispered, "Nothing natural decouples from its own nucleus." Reeves swallowed hard. "This thing isn't bound to the nucleus because it is the nucleus." Grant stared at the monitor, his eyes hollow.
"So we're not looking at ice," he said softly. "Not dust, not a core. We're looking at a device." Harlow didn't contradict him. He couldn't, not anymore. He pulled up frame 6, the one he had unplugged earlier. He knew they had to look again, no matter how much his instincts protested. The frame loaded slowly, the image building line by line. The coma expansion, the symmetric halo, the central void, and that aperture-like shape staring down the barrel of the telescope. It felt obscene in its clarity, too aligned, too centered, too timed. "Why did it align with our camera?" Grant asked. Liu shook her head. "We don't know that it aligned. It might be coincidental." But even she didn't believe that. The timing was too exact, the flash too synchronized, the orientation too perfect. Reeves' voice trembled for the first time. Not from fear, but from exhaustion, from the collapse of everything familiar. "It acted," he said, "and we recorded the action." Harlow stared at the screen a long time. Then he spoke the most dangerous sentence a scientist can say. "This isn't a comet." He didn't offer an alternative. He didn't need to. Everyone in the room had already crossed that line internally. The final blow came at 5:16 p.m., when Liu pulled up a multi-frame comparison of the hexagonal structure. She removed the coma interference entirely, leaving only the cleaned outline. The sequence showed frame 3, hexagon; frame 4, modified hexagon; frame 5, contraction along one side, correlation with thrust origin; frame 6, aperture-like rotation toward the camera. 4 distinct configurations, 4 deliberate geometric states. Not chaos, not drift, not ice, not erosion. A mechanism. Something with modes, configurations, engineering behavior. Liu clicked the animation again, and again, and again. The room remained silent for a full minute. Finally, Harlow stood. His chair scraped the floor behind him. "We can't keep this here." Reeves looked up sharply. "Are you saying we report it?" "I'm saying," Harlow replied, "that whatever we're looking at is beyond us, and we need verification." Liu crossed her arms tightly. "If we send this up the chain, it disappears." "I know. So why do it?" Harlow's voice softened. "Because science isn't about what we want, it's about what is." He shut off the monitor, not by pulling the plug this time, but slowly, deliberately, with a practiced hand. "We'll package the data, we'll send a preliminary report, and then we'll see what happens." Grant felt a spike of hope. Maybe this would lead to a breakthrough, a discovery, a new chapter in interstellar science. But Liu's expression killed that hope instantly. "Dan, you know what's going to happen." Harlow didn't answer, because he did know, and within 12 hours, her prediction would prove correct. The data would vanish, the report would be sealed, and the story of the hexagonal structure inside 3I-Atlas would officially cease to exist. But unofficially, for the people in that room, it had just begun. The morning after the team filed their sealed preliminary report, the University of Colorado campus looked aggressively normal. Students crossing the quad, cyclists weaving between pedestrians, a group of freshmen taking photos with the buffalo statue outside the science building. The everyday calm of people who had no idea that 60 feet away, behind a locked interior door, 6 researchers were sitting in a conference room without speaking, without touching their coffee, without quite knowing what to do with their hands. They were waiting for the email, waiting for the phone call, waiting for the verdict. They'd sent the data at 11:41 p.m. By sunrise, the message had reached NASA's Planetary Imaging Review Board, then ESA's NEO Coordination Center in Italy, then the Jet Propulsion Laboratory in Pasadena. 6 images, 6 anomalies, 1 structural impossibility. The team expected questions, expected requests for calibration files, dark frames, flat field references, expected pressure. What they didn't expect was silence. Harlow checked his phone for the 15th time. Nothing. Rue sat with her arms crossed, elbows tucked tightly against her ribs like she was bracing for impact. Grant hadn't slept at all. His hands shook. He tried to steady them by gripping a plastic so tight that the plastic creaked. Reeves, the technician, stared at the empty table in front of him, his expression unreadable. He looked like someone waiting for a diagnosis he already knew he didn't want. Finally, at 9:03 a.m., a notification chimed. Everyone stiffened. Harlow unlocked his phone, scanned the message, and exhaled. "It's an acknowledgement, that's all." "From who?" Liu asked. "From NASA's Planetary Imaging Review Board." "What did they say?" Harlow read aloud. "Data received. Under evaluation. Hold all further processing until instructed." That was it. No technical questions, no follow-up requests, no skepticism, just a freeze order. "They saw something," Reeves said quietly. "Or they don't want us to see more," Liu replied. But the story wasn't finished with them, not even close. Because while NASA and ESA were freezing the ground beneath their feet, something else was happening 6 million miles away. something that would force itself back into their hands whether they wanted to or not. It started at 10:42 a.m. A notification flashed on the observatory's internal monitoring system. Unexpected photometric variation in 3I-Atlas. At first, the anomaly looked small, a brightness spike outside the predicted curve, something you could blame on noise, or dust, or turbulence. But then came a second spike, stronger, sharper, then a third. And then, buried inside the photometric noise, something else surfaced. A pulse. Faint. Fast. Precisely timed. 16.16 hours was the known pulse cycle of Atlas, the breathing period. But this was different. This new pulse occurred on a 12-minute interval. Reeves saw the alert first. "Oh God," he whispered. "It's doing it again." Harlow rushed to his workstation. "What are we looking at?" "Directional intensity shifts, multiple, repeating, and not random." Liu leaned over his shoulder. 12 minutes? That's the same interval as the reoriented streams in frame 5. Grant paled. "It's preparing for another maneuver." The words hung in the air like smoke. And then the system chimed again. A second alert, this time not photometric. Trajectory deviation detected. Harlow froze. That can't be right. Reeves pulled up the model. The plotted path of 3I-Atlas, a smooth line curving inward toward its predicted perihelion, now showed a tiny kink, a gentle bend, a deviation of 0.004 degrees. It was small, but not nanoscopic, not ignorable, and definitely not natural. Comets don't make course corrections in 12 minutes. Rocks don't adjust vectors against solar radiation. Nuclei don't anticipate thrust. But something inside Atlas did. Reeves whispered, almost afraid to raise his voice. "It's maneuvering." The next hour felt unreal, like watching a slow-motion disaster unfold at a distance too far to stop, but too close to ignore. They ran triple checks, cross-referenced with JPL data, pulled independent observations from amateur astronomers in Australia and Chile. Every source said the same thing. Atlas had nudged itself, a nudge too precise for outgassing, too clean for stochastic thrust, too fast for radiative torques. Harlow stared at the model until it blurred. What is it avoiding? Or what is it aiming for? "Jupiter," Grant said. Everyone turned to look at him. "What are you talking about?" Liu asked. The last gravitational interaction, the near miss, the one Avi calculated the probability for, that trajectory didn't make sense then, and this one doesn't now. "You're suggesting it's targeting Jupiter?" Liu pressed. "I'm suggesting that nothing about its orbital mechanics is accidental."
Harlow opened a new window and overlaid the previous close approach path with the current deviation. The lines aligned disturbingly well, not an exact match, but consistent. "You can't say it's steering," Liu muttered. "You can't." But she didn't sound like she believed herself. Grant leaned closer. "It's the same behavior we see in controlled spacecraft. Small impulses, corrections, keeping a specific relative angle to a moving, massive body. You'd do that if—" "Don't finish that sentence," Harlow cut in. But he didn't have to. Everyone was thinking the same thing. Station keeping is not something a comet does. At 12:15 p.m., Reeves ran a time-compressed animation of the photometric stream data, every recorded pulse from the past 36 hours stitched into a single visualization. What appeared was horrifying. Not visually. Visually, it looked simple, like a heartbeat chart. But the implications.
Each spike followed another with surgical consistency. Each trough dipped with mechanical regularity. And then, every 6 spikes, a high-intensity cluster appeared, the same pattern seen during the first maneuver. "Those are ignition events," Lou whispered. Grant nodded slowly. "Thruster cycles." Even saying the words felt sacrilegious. "This isn't a comet," Reeves said, barely audible. "This is a vehicle with a damaged disguise." The disguise, the coma, was a natural phenomenon, but what it was hiding hadn't been natural for a very, very long time. "Could we be misreading the timing?" Harlow asked. "No," Reeves replied, "because it just happened again." Another brightness spike, another vector adjustment, another tiny deviation. 3 maneuvers in under 2 hours. The room vibrated with tension. This was no longer an academic puzzle. This was behavior, predictive, reactive, directed. They weren't studying an object. They were watching a process. At 1:06 p.m., everything changed. The lab lights flickered, not because of power failure, but because someone from the university's administration manually locked down the research floor. A coded alert flashed on every monitor. All further access to 3I datless data temporarily suspended. Do not continue analysis. Security review in progress. And beneath it, a signature. NASA ESA Joint Internal Security Directive. Lou exhaled sharply. "They're shutting us down." "We expected this," Harlow replied. "The data was too anomalous." Grant shook his head. "No, Dan, this is different. They didn't just tell us to stop. They locked us out." Reeves stood up abruptly, knocking over his chair. "We still have local copies of the frames. They're in RAM from the earlier analysis. If we don't export them now—" "Don't," Harlow warned. Reeves paused, breathing hard. "It's evidence," he said. "It's restricted," Harlow countered. "We follow protocol." "Protocol?" Reeves snapped. "Protocol says objects don't change shape. Protocol says comets don't generate thrust. Protocol says there isn't a—" "Stop," Harlow said sharply. Reeves shut his mouth, but his eyes burned. The team stood in an uneasy circle, the pressure closing around them like a tightening vice. Grant spoke softly. "Dan, what if this isn't a lockdown because the data is wrong? What if it's a lockdown because the data is right?" Harlow looked exhausted. "What are you implying?" "I'm implying," Grant said carefully, "that someone already suspected Atlas wasn't natural, and they needed confirmation." A heavy silence. Then Lou added quietly, "And now that they have confirmation, they don't want 6 civilians being the only people in the world who understand what they're dealing with." The words stung, because they were probably true. But before anyone could process the implications, Reeves' console chimed again. Unauthorized access block. Then another. Then another. "What the hell?" Reeves muttered, typing rapidly. "What's going on?" Harlow asked. "Someone is trying to remotely purge our local storage buffers." Lou's eyes widened. "They're wiping us." Grant's heart hammered. "Dan, we can't lose the frames, the structure, the thruster vectors, the maneuver." "I know," Harlow said. "Reeves, isolate the machine, pull the network." Reeves yanked the Ethernet cable from the wall so hard the plastic cracked. The room went quiet. They waited for a message, a reprimand, a threat. But none came. Instead, Reeves stared at his screen in disbelief. "Guys," he whispered, "something new is happening." Harlow turned. "What?" "The photometric feed from Lowell Observatory. It's still public, and Atlas just began another maneuver." Lou rushed over. "Let me see." Reeves pointed at the real-time graph. A brightness spike, then another, then a plateau, then
a directional surge so strong it clipped the top of the graph. "Holy," Grant breathed. "That's not a correction. That's a burn." The room snapped into motion. Harlow, track its trajectory. Reeves, on it. Lou, compare with predicted model. The updated path appeared on screen. Atlas had accelerated, cleanly, deliberately, and not just away from some hazard, not away from the sun, not toward Jupiter. It was adjusting to maintain a specific radial orientation to Earth. Lou stepped back, her face pale. "It's responding to our observation again." Grant shook his head violently. "No, that's impossible. We're not emitting anything that could influence it. Our telescopes aren't—" "It doesn't need influence," Lou said. "Just awareness." Harlow felt something cold settle into his chest. Not fear, not awe, recognition. "Frame 6, he said. "The orientation, the flash that matched the shutter, the sequence correlation." Reeves nodded slowly, dread pooling behind his eyes. "It was never aligning to the camera," he whispered. "It was aligning to Earth." A long silence. No one spoke, no one moved. The only sound was the hum of the workstation's cooling fan. Finally, Grant broke the silence. "If it's maneuvering to maintain a relative angle to Earth, then it's not avoiding anything." Lou finished the thought. "It's observing." The word echoed. Observing. Then came the moment that would later be described in classified meeting minutes as the inflection point. At 1:22 p.m., the Lowell Observatory feed registered a sudden darkening in the inner coma, a decrease in brightness that didn't correlate with position, angle, or dust density. Reeves zoomed in. "What is that?" Grant asked. Reeves enhanced the image. The dark zone expanded, deepened, clarified, then shaped itself. Not a hexagon this time, not a shell, not a boundary, a slit. A long, narrow, symmetric void, like something retracting or opening. Lou took one step backward. "No, no, no!" Harlow leaned closer. "What are we looking at?" Reeves swallowed. "A vent." "A vent?" Grant echoed. Reeves nodded slowly. "A controlled exhaust vent, aligned with our orbital direction." A chill ran through the group. Atlas wasn't just maneuvering, wasn't just observing, wasn't just station-keeping. It was preparing something precise, something directed, something with intent. And at 1:24 p.m., the vent flared. A brief, narrow, perfectly linear emission, a beam of dust or plasma, or something too faint to categorize. It wasn't a signal, not in the radio sense, not in any intentional communication pattern, but it was unmistakably deliberate. Reeves whispered, "It's not random." Lou covered her mouth. Grant's voice cracked. "What do we do now?" Harlow didn't answer, because in that moment he realized something terrifying. No one on Earth was prepared for what was unfolding. No one had a protocol for a maneuvering interstellar object. No one had a plan. The team wasn't watching history. They were watching precedent shatter, one frame at a time. There are moments in science when the world doesn't change all at once. It changes slowly, molecule by molecule, until a final detail snaps the entire picture into focus and you realize you've been looking at something enormous without understanding it. For the research team in Boulder, that snap happened at 1:24:17 p.m. when a vent-like structure inside 3I Atlas opened and released a thin, perfectly linear plume
That should not have existed. It wasn't strong enough to detect in radio, wasn't energetic enough to flag on any automated system. But it was narrow, deliberate, targeted.
and it was aimed, however faintly, along a vector that intersected Earth's orbital position. After that, there were no metaphors, no jokes, no speculation, just silence. A silence that felt like the space between lightning and thunder. For the next 5 minutes, no one moved. Reeves kept staring at the screen, one hand hovering above the keyboard as if touching it would make the whole thing evaporate. Liu stood frozen with her arms wrapped around herself, breathing shallowly, her academic composure hanging by a thread. Grant's knees buckled. He sat slowly, like a man trying to keep his body from betraying the shock. And Harlow, the one who always had something to say, had gone quiet in a way that terrified everyone. Then, the second flare appeared. Not bright, not energetic, but unmistakably structured. A split-second pulse, like a shutter opening and closing, but directed outward, not inward. "Replay that," Harlow murmured. Reeves did. The flare appeared at the exact moment the object's inner geometry shifted. A faint change in the coma's silhouette, a ripple in dust at the edge of the nucleus, a rotation of the aperture-like cavity inside the hexagonal shell. It looked like a mechanism cycling. Grant whispered, "It's scanning." Liu snapped, "You don't know that." But her voice didn't sound convinced, not even close. Reeves isolated the flare intensity curve. It rose sharply, too sharply to be random dust scattering. The gradient looked technical, controlled, a power-on profile, not a chaotic outburst. Then came the part that ended everyone's ability to pretend. At the moment of the flare, the coma thinned for just a heartbeat, exposing more of the structure beneath. Enough to reveal the geometry not as a hexagon, not as a single plate, but as a layered assembly. Surfaces nested inside surfaces, articulated segments, panels flush against each other, then shifting with mechanical precision. It wasn't grossly alien. It wasn't glowing. It wasn't strange in a science fiction way. It looked engineered, practical, functional. A machine buried inside dust and ice. Frame 6 had shown the aperture, but now, for the first time, the team saw the architecture. And that changed everything. "Stop the frame," Harlow said quietly. "Zoom the center. No interpolation." Reeves froze the moment of maximum geometric clarity and magnified the inner region at full resolution. A shape emerged, faint but undeniable, like a ribbed assembly. 5 curved ridges, a central cavity, 2 supporting struts partially obscured by dust. Liu looked physically ill. That's not geological," she whispered. "It's not fractal," Grant said. "Not random. Those angles are too regular." Reeves pointed. "Look at the interval spacing. Identical. All 5. Harlow leaned closer. His eyes sharpened in the way they did when something didn't just break his expectations, it rewrote them. "That's a repeating pattern," he said. "Equal length features." "And mechanical features repeat," Grant added. "Natural ones don't, not with that precision." Reeves enlarged the ridges further until the pixels blurred. Grant swallowed. "It looks like heat shielding." Liu flinched. "Don't anthropomorphize. You don't know that." "Then why is it ribbed?" Grant said. "Why does it have expansion channels? Because your brain wants to see patterns," Liu snapped. She stopped. Because the next frame loaded. Reeves hadn't clicked anything. The system simply processed the trailing data from the observatory feed and updated the image stack. And suddenly, before anyone could speak, the object inside Atlas moved again. Not rotated, not reoriented, moved. An internal shift, a contraction of one of the ribs, a subtle pivot of the central cavity, all synchronized with the faint flare. "Oh my God, that's coordinated motion," Liu whispered. Grant, stunned. Why would a comet have coordinated motion? No one answered, because there was no answer. Not one grounded in physics, not one grounded in geology, not one in anything humans had ever observed from an interstellar visitor. Then, something happened that made the room lurch. The flare aligned perfectly with a timestamp in their initial 6-frame series. It matched the moment the camera shutter fired. In other words, the maneuver they were watching now mirrored the maneuver from the original frame 6. This wasn't a coincidence. It wasn't random alignment. It was a pattern, a repeatable pattern. Atlas had done this before. They had captured it. They just hadn't known how to interpret it. Now, with the new data aligning with the original snapshots, the only reasonable interpretation was terrifying. Atlas was cycling, not in a natural sense, not thermally, not mechanically from rotation. It was executing a timing sequence. It's periodic, not random, not reactive, programmed. "Or biological," Liu said quickly. Harlow shook his head slowly. "Biological systems don't produce geometric articulation like that. Not at that scale, not at cryogenic temperatures, and not inside a debris shell." The room filled with the sound of people trying not to panic. The third flare arrived with no warning. This time it was brighter, sharper, longer. 3/4 of a second, an eternity compared to the others. The coma flashed white along a narrow band, then rippled outward, like light reflecting through fog. The expression on Reeves' face changed from confusion to dread. "Jesus Christ," he whispered. "That wasn't dust." Grant leaned over him. "What do you mean?" He whispered, "That was particulate ignition, a burn event, like an exhaust valve clearing debris." Liu froze. "Exhaust? You think it's—" Reeves didn't let her finish. He played back the frame stack at quarter speed. The same vent slit from earlier opened again, clean, straight, almost surgical, and a burst of microparticulates shot outward, lined with a faint plasma halo. It wasn't propulsion. It wasn't directional. It was maintenance. A purge cycle. A system clearing its throat. Something inside Atlas was no longer just reacting to stress. It was operating. Harlow closed his eyes. "We need to call this in." Liu nodded slowly. "Dan, this is beyond us." Grant ran a shaky hand through his hair. "We're not equipped to handle an engineered interstellar—" "Don't say that word," Harlow snapped. "Not until we have absolute confirmation." Reeves quietly murmured, "What if confirmation is already here?" Everyone turned. He pointed at the screen. "You're all looking at the vent, but look at the coma thickness at each burn." Harlow leaned forward. Reeves dropped the opacity, revealing faint pressure gradients in the dust. The coma was reacting asymmetrically, not because of heat, not because of solar pressure, but because of something pushing outward from within. Impulse. Not explosion, impulse. Grant whispered, "It's repositioning its shell." Liu choked on her disbelief. "Why would it need to?" Harlow whispered the only possibility: to maintain stability during operation. The words tasted absurd, wrong, like a violation of reality. And yet, there they were. The coma wasn't random anymore. It wasn't chaotic. It was moving with purpose. The fourth flare arrived 2 minutes later. It wasn't brighter. It wasn't longer. It was aimed. For the first time, the vent didn't point along the object's trajectory. It didn't align with Earth. It didn't push against the solar wind. It aimed toward the sun. Reeves whispered, "That's backwards." Grant said, "Nothing pushes into solar radiation. Nothing. unless it's trying to break. That hit the room like a gunshot. Harlow spoke only one sentence. Pull the orbital derivative. Reeves ran the model. Atlas slowed. Not much. Barely more than a fraction of a fractional percent. But that deceleration lined up precisely with the flare. The team stared at the screen. "Why would it slow down?" Grant asked hoarsely. Lou whispered, "Because it's preparing." "For what?" Grant asked, cracking. "For another operation." She whispered. No one could breathe.
Then came the twist. A notification pinged on Reeves' console. Not from NASA, not from ESA, not from any official channel. It was from a public observatory in Flagstaff, Arizona, Lowell Observatory, where a volunteer programmer had been running a homebrew photometric script on Atlas for weeks, unaware that anything extraordinary was happening. The message was simple. "We're seeing geometric oscillations in the coma. Are you?" Reeves read it twice. "They're seeing it," he whispered. "Someone outside our building is seeing the structure." Harlow's stomach dropped. This wasn't contained. This wasn't theirs to hide. The data was leaking. Not through malice, not through whistleblowing, but through nature. Atlas wasn't subtle anymore. It was broadcasting. But not in any typical sense. It wasn't sending signals. It wasn't transmitting data. It wasn't calling out. It was simply doing something so physically anomalous that anyone with a telescope and the right timing could see hints of it. That realization, that the universe itself was making disclosure inevitable, terrified Harlow more than anything else so far. If amateurs were seeing geometry, if students were noticing oscillations, if researchers across states were capturing faint vent pulses, then control was slipping, and fast. Reeves checked the live feed again. "Guys, it's happening again. The fifth flare, a long one, clean, controlled. But this one didn't scatter dust. This one illuminated the interior." For half a second, the coma cleared, like a curtain pulling back, and the researchers saw, clearly this time, the full internal assembly. Not all of it, not enough to understand, but enough to know with absolute certainty that nothing inside Atlas was natural. Ribs, panels, supporting framework, an internal cavity ringed with concentric structures. It looked less like a nucleus and more like the inside of a heat shield or a mechanical housing. Harlow's breath hitched. Reeves whispered, "Should I take a screenshot?" "No," Liu said immediately. "If you save anything local, they'll lock us out of the entire network." Grat shook his head. "But if we don't save it, it'll disappear." Harlow's voice cracked. "Everything disappears." That line made everyone go still, because they all knew what he meant. When the agency stepped in, the record would be lost. The public channels would be scrubbed. The internal logs sealed. But the memory would stay. Reeves whispered, "There's a final detail." "What?" Harlow asked. He enhanced a region near the central cavity, a faint signature hidden in the noise. A reflection. A faint reflection. Angular. Consistent. Perfectly timed with the flare. Grant choked. "No. No way, It's not an eye," Liu snapped immediately. "I didn't say that," Grant shot back. "It's a reflective surface, a sensor, a photometric gate," Reeves added quietly. "Or a lens." That word hung in the air like a threat. Not mystical, not conscious, not a face, just a lens. A simple, functional, inevitable consequence of a system designed to monitor its environment. A lens pointed at the sun. A lens pointed at the stars. A lens pointed at Earth. And at them. Then the coma brightened again, violently. A flash. A bloom. A scattering shockwave. Reeves recoiled from the screen. "What is that?" The shell's destabilizing, Liu breathed. No, Harlow said. It's venting. On purpose. And then came the final detail. The debris pattern from the flare aligned at a perfect angle of 43 degrees relative to Earth. Not random, not chaotic, aligned toward Earth's orbital plane. Not a message, not a threat, not communication, just geometry. But geometry has meaning. And the flare had intent. For the first time, Harlow spoke the truth they had all been avoiding. It knows we're watching. No one responded, so he finished the sentence. And it wants us to. It took 27 minutes. 27 minutes from the moment the fifth flare lit up the coma, illuminating ribs, panels, vents, and that reflected glint, to the moment the research team's entire world collapsed into silence. The first sign was subtle. The network latency ballooned. Terminals slowed. Data windows froze. A few icons grayed out, not with error messages, but with that sterile, bureaucratic kind of stillness that feels planned. Then the university server issued a soft chime, one nobody there had ever heard before. A red banner slid across every screen. NASA ESA Joint Security Directive Level 3, temporary lockdown in effect. All access to 3I Atlas material is suspended. Do not continue analysis. Do not transfer data. Stand by for contact. The words didn't feel real. They felt like a bad simulation. The first to speak was Reeves. Level 3, he whispered? That's not even used for classified asteroid impacts. Harlow said nothing. Liu's voice was flat. It's not used for anything. Grant stood up so fast his chair fell. The bang echoed through the room. No, this can't happen. Not now, not after what we saw. Reeves, pale. We should have exported the frames. We should have saved a copy. Harlow snapped. And done what? Put them on Reddit? Email them to journalists? Get ourselves blacklisted from every observatory on Earth? Grant's voice broke. At least they'd be out there. Enough, Harlow said. But it wasn't enough. The silence that followed was hotter than any argument. Then a soft alert appeared, this time from the building's internal system. Lab access restricted. Do not exit. Do not admit personnel. Security team en route. Jesus, Reeves murmured. They're sending physical containment. Liu hugged herself. Lee think we're a leak risk. Grant's laugh was hollow, humorless. We are a leak risk. They all turned to Harlow. He looked older than he had 20 minutes ago. Older and tired in a way that went past exhaustion. Everyone stay calm, he said. We didn't do anything wrong. But everyone in the room understood something he wasn't saying. If the agencies were locking everything down this aggressively, it wasn't because the data was flawed. It was because the data was right. A soft buzz vibrated through the floor. The elevator stopping. Bootsteps approached from the hallway. The team stiffened. We're not under arrest, Harlow whispered. This is protocol. Liu nodded mechanically, but her knuckles were white around her water bottle. The footsteps stopped outside the door. A coded knock. Then a voice. Dr. Harlow, we're here for data collection. Harlow opened the door. And two individuals stood there, polite, expressionless, wearing badges that looked real, but had no agency logo. A third was right behind them, rolling a secure equipment case. May we enter? The lead asked. Harlow stepped back. Of course. The agents moved quietly, efficiently. No intimidation tactics, no raised voices. They simply began sealing devices, computers, drives, external monitors, tagging each with barcodes. One of them approached Reeves. We'll need your workstation. Reeves hesitated, then stood up. It's still got residual data in RAM. That's why we're here, the agent said kindly. Reeves stepped aside, as if stepping away from a dying patient. The agents worked silently for 10 minutes. Then the lead turned to Harlow. We'll be taking custody of all raw frames and derivative files. A summary report will be available to you after review." Grant barked a laugh. "A summary? You're erasing everything." The agent remained calm. "Nothing is being erased. It's being secured." Liu whispered, "Secured for who?" The agent didn't answer. No one expected him to. Within minutes, the room was stripped clean. Drives removed. Terminals powered off. Local caches vacuumed. Even the optical ports on the workstation were sealed with tamper-proof stickers. Before leaving, the agent placed a final document on the table. Temporary non-disclosure agreement issued under joint agency authority, valid for 180 days. Violations subject to federal penalty. Grant stared at it like a snake. Liu didn't move. Reeves looked like he might vomit. But Harlow just picked it up, read it, and sighed. He signed. One by one, the others did too. The agents thanked them, and left. When the door closed, the room felt suffocating. Then, when everything seemed like it was over, something unexpected happened. A soft ping, very soft, from the far side of the lab. Reeves spun around.
What was that? It wasn't a computer. Everything was shut off. He walked closer, scanning the tables. Then he froze. A small tablet, his personal one, had lit up. He'd left it in his backpack. He hadn't touched it since yesterday. On the screen, a notification. New message received. Flagstaff, Arizona. Lou rushed over. "Reeves, no. Don't open it." "It's not from NASA," he said. "It's from—" His voice cracked. "It's from the volunteer at Lowell Observatory." Harlow closed his eyes. "Open it," he said. Reeves tapped the notification. A single line of text appeared. "We recorded the flare. You saw it too, right?" And attached, not a thumbnail, not a compressed image, but a raw photometry capture. Reeves blinked. "They caught the vent." "Impossible," Harlow said weakly. "The flare was too faint for small mirrors." But the image told a different story. It wasn't perfect, but it was unmistakable. The vent slit, the plume, the geometry. The amateur had captured frame 6, not their frame 6, but another one, a new one. Proof. Outside institutional control. Grant's mouth fell open. "It's out," he whispered. "It's not just us." Lou exhaled shakily. "We're not the only witnesses." Harlow stared at the screen, then whispered, "The universe leaked it for us." The next hours blurred. The team sat in the dimmed lab, stunned and quiet, listening to the hum of the ventilation system and the pulse of the campus outside. They should have felt relief, vindication, hope. Instead, they felt dread. If a volunteer could capture the vent, how long before someone else did? Another observatory, an amateur with a better telescope, a YouTube channel scraping live feeds? Control was already slipping. NASA had issued a moratorium. ESA had locked down the servers. But the universe didn't care. The universe had given them a comet with a secret, an interstellar visitor with mechanisms inside, a structure that rotated, vented, shifted, and maneuvered, a structure that aimed, a structure that responded, a structure that— A soft vibration buzzed through the table. Reeves' tablet, again. Another message. He opened it, hands shaking. This one wasn't from Flagstaff. It was from an amateur observatory in Chile. Just one sentence. Do you see the symmetry in the core? It's lined up to Earth's ecliptic. Again. Harlow's spine tingled. Another ping. This time from a facility in Japan. Another from Mexico. Another from France. All uncoordinated, all describing the same event. A new reorientation inside 3I Atlas. A repeat of the geometric pattern. A shift toward Earth's orbital plane. A behavior no natural comet could replicate. Reeves whispered, "It's broadcasting through physics." Lou corrected him. "It's visible. That's worse." Grant looked like he couldn't breathe. If we're the first ones who understood, we're the witnesses of a maneuvering interstellar craft, and now half the planet might accidentally confirm it. Harlow didn't speak. He stared at the screen, reading message after message from observers across the world, each describing the same impossible alignment, and he realized something horrifying. The agencies weren't suppressing a discovery. They were suppressing a panic. Because if this ever became public, if the world learned that an interstellar object wasn't a comet, wasn't random, wasn't passive, but actively maneuvering, there'd be no containing the reaction. Not scientifically, not politically, not psychologically, but nature had already outpaced them. And there was no going back. The sun was setting when the last message arrived. Not from a volunteer, not from an observatory, from an automated sky monitoring bot. Random, unfiltered, untagged. But it included a still image, a blurry one, grainy, low fidelity, yet the shape in the center, the faint hexagonal silhouette, the dark aperture, the alignment toward Earth. It was frame 6. Not their frame 6, but the same geometry, the same configuration, captured accidentally by a machine designed to monitor meteors and aircraft. Grant stared at it. Harlow stared at it. Then Lou, voice trembling, whispered the final truth. It doesn't matter what the agencies sealed. It doesn't matter what they erased, Reeves finished the thought. Because the object didn't hide, and the universe didn't cooperate. Finally, Harlow said the thing none of them wanted to say, but all of them had understood since the moment the comet showed them a vent. This isn't a discovery anymore. He looked at them, each of them, slowly, deliberately. This is contact through observation. The room froze, and Harlow added, and the next move isn't ours. The final message of the night came 2 hours later. A new email, anonymous sender, no signature, no greeting, just one line. A single, devastating sentence. The structure inside 3I Atlas is reacting again.
And this time, it's reacting to us. Attached was one image. Dark, blurry, poorly framed. But in the center, smack in the middle of the coma, a faint geometric shadow. Not a shape, not a panel, not a vent. A shift, a reorientation. One that lined up perfectly with Earth. The research team stared at it until nobody could deny what it meant. Not a message, not a signal, not a threat, just a reaction. A simple, physical, undeniable reaction. And the last line of the story, the one that would echo in their minds long after the agencies sealed everything away, formed itself silently on every tongue. Because it wasn't just a structure anymore. It wasn't just geometry. It wasn't just a mechanism. It was awareness expressed through physics. And the only thing more terrifying than an interstellar object responding was the realization that it had been responding all along.